celebrated natural feature, the Old Faithful Geyser, are some of nature's greatest wonders. But beneath this primal beauty simmers a hidden threat. 5 miles below the waterfalls and mountain peaks lies the heart of a supervolcano, a constantly moving cauldron of molten rock the size of Mount Everest. Over countless millions of years, it fills with lava to the breaking point. Like a bomb with a hidden timer, it finally explodes.
We don't know how long it's going to just sit there before it decides to go off.
If sometime in the future it were to erupt, as it has before, the Yellowstone volcano would overwhelm everything within 100 miles and disrupt lives across the globe for years. The first sign of trouble will be increasing seismic activity. The ground would rise as pressure from the molten rock begins to grow.
There would be a lot of ground deformation, and then if it was moving up slowly enough, we would actually start seeing large changes in the geyser basins.
Finally, the lava would shatter the Earth's surface with an explosion 10 times larger than Mount St. Helens. A hurricane of hot gases would spread out in all directions as the ash cloud reaches 80,000 feet into the air. Already larger than anything man has experienced, this would be just the beginning of a Yellowstone supereruption. Within days, a second enormous eruption would begin, then another. Soon, a ring of monstrous explosions 50 miles wide would be spewing molten rock and burning gases across the landscape.
Certainly within 100 miles of Yellowstone, there wouldn't be much that was not destroyed.
High in the atmosphere, the ash cloud would surround the planet, sending temperatures plunging. Global agriculture would fall into chaos. How do we know it will happen? Because it's happened before. The evidence is etched into the geologic record of past supervolcanoes. There are 1,500 volcanoes around the world. But there are fewer than 10 supervolcanoes. The ones with the potential to not only destroy the surrounding area, but to create a global disaster. And Yellowstone is one of these supervolcanoes.
Imagine something 10,000 times the size of Mount St. Helens. It's almost unimaginable.
Unlike a conventional volcano with its crater atop a mountain, Yellowstone's crater is so large it can only be seen from the air. This is the rim of a monstrous crater called a caldera that collapsed into the magma chamber during the last supereruption. It's large enough to hold the city of Los Angeles.
People drive 35 miles, 45 miles commuting to work in that. Well, that's the distance across this caldera.
And this is only the last of 3 monstrous calderas formed over the past 2 million years.
The volcanic history of Yellowstone is really marked by these 3 giant cataclysmic eruptions of the scale that we haven't seen in, history of man, really.
The first eruption vented somewhere around 600 cubic miles of material. And if you took all of that and you spread it out over the state of Texas, you'd have about 12 feet thick of deposits.
The second eruption was hundreds of times larger than Mount St. Helens, and it's the smallest of the Yellowstone supereruptions. The most recent one, known as the Lava Creek eruption, occurred 640,000 years ago. At the time, early man had yet to arrive on the scene. Exotic prehistoric animals roamed the North American continent. 5 miles beneath the Earth, however, a magmatic cauldron 3 times the size of New York City was coming to a boil.
There would have been hundreds to thousands of earthquakes becoming fairly large, so there'd be a lot of shaking as the hot rock was moving up.
1 million tons of molten rock heated to 1,800 degrees Fahrenheit pressed its way to the surface. Jets of superheated water suddenly burst through the cracks in the Earth's surface, shooting into the air. Hundreds of geysers were erupting over 500 square miles.
we get explosions out of the hydrothermal system that put holes in the ground as big as a mile across. So they're big events.
But this was just the overture before the main event. After days of increasing earthquake and geyser activity, under mounting pressure from magma and superheated gases, Yellowstone's last super eruption began.
Material may have started to leak out of one side, perhaps forming part of the edge of the fracture zone. As you start to decrease the pressure, it starts to then explode.
With the power of a hydrogen bomb, a monstrous cloud of searing ash and melted rock shot into the stratosphere at supersonic speeds. The heavier debris fell back to the ground, turning into colossal pyroclastic flows.
It was sort of like a hurricane made up of 800-degree ash and pumice and hot gases. Just wipes things out completely.
For miles, these lethal rivers of ash and gas cooked animals alive and brushed forests aside like twigs.
They extend actually outside of Yellowstone into Idaho and into the Teton region. Some of this material flowed down and actually covered parts of the floor of Jackson Hole. So these things extend tens of miles away from the actual eruption location.
For days, the Yellowstone volcano continued to heave tons of molten debris into the air and devastated the nearby terrain. Then, across the caldera, another colossal explosion. Then another. Eruption after eruption began shooting more and more lava and pulverized rock into the air.
Typically, when these eruptions begin, they begin at a single vent, and the event may then get larger, moving out along some sort of a fracture system.
Yellowstone had turned into a super eruption. Its devastation would reach around the world. Yellowstone's last super eruption occurred 640,000 years ago. It started as a single massive volcano, but soon turned into a series of eruptions, exploding with the full force of a supervolcano.
The entire sequence of pyroclastic explosions that formed the Yellowstone caldera may have taken as little as 2 weeks to happen.
Pyroclastic flows slashed across the landscape, obliterating thousands of square miles. Separate clouds of ash fused into a massive column of smoke. Winds drove it across the country, darkening the sky for hundreds of miles.
During the eruption of all this material, that's when the caldera would have started forming.
In a final massive display of nature's fury, hundreds of square miles of mountain dropped thousands of feet into the pit of roiling magma.
The Gallatin Range and the Madison Range and the Mount Washburn Range to the north continued somewhere into the Yellowstone region. These mountain ranges were destroyed. Now, when I say destroyed, I don't mean they were blowing the smithereens into the atmosphere. Much of it just fell back into the magmatic system, just fell back into the cauldron, if you wish, up the caldera itself.
We're talking about mountains that might be 12,000 feet high that are now, the ground surface is on the order of 8,000 to 9,000 feet high. So 3,000 foot of mountain that is no longer there.
Finally, after perhaps weeks of constant activity, the Yellowstone volcano subsided. But the devastation was far from over. A global disaster was about to begin. 2.5 trillion tons of sterile volcanic ash drifted with the winds and buried 2,000 square miles of the North American plains, destroying much of the continent's plant life.
The volcanic ash that's ejected high up into the atmosphere and then falls many, many miles away, that goes as far as Louisiana and some of the states along the Mississippi River. So quite an ash cloud.
The lighter particles remained in the air for more than a year, forcing temperatures to plunge across the hemisphere.
It acts as a veil and cuts out the sunlight, and so it cools the climate below. I think there would certainly have been climatic changes due to Yellowstone. We estimated 3 to 5 degrees Celsius drop in temperature, which is quite severe on a global basis.
5 degrees was enough to kill off much of the tropical plant life across the globe. Over the next year, animals died from lack of food as the ash continued to block out the sun. It took years for the planet to recover, for sunlight to reach the Earth's surface, for plants to push through the layers of ash, for animals to repopulate the continent. This Yellowstone eruption 640,000 years ago changed the face of North America. But that wasn't the only supereruption to ever strike the area. Besides the 3 calderas found near Yellowstone Park, geologists have discovered a series of eruptions and supereruptions that extend back 16 million years.
There have been a series of volcanic eruptions similar to those that occur at Yellowstone, and there are all sorts of calderas that are preserved in the Snake River Plain in Idaho and extending back into Nevada.
To date, 15 calderas of more than 140 large eruptions have been mapped. They create a trail running northeast to southwest and are an indication of what geologists call a hotspot. A hotspot is a portion of the Earth's mantle that contains a massive pool of partly molten rock.
There is an area within the Earth's mantle, deep underneath where we live, that is molten, and it's causing a lot of heat to rise towards the surface, and that heat causes melting in the crust, and so we get large magma chambers.
From time to time, as the pressures build, the magma works its way to the surface and explodes.
There are 20 or 30 hotspots around the Earth's globe, such places as Hawaii and Iceland. These are long-lived zones of active volcanism.
The Hawaiian Islands, for example, were created one by one over the millennia by an underwater volcano. Though it appears as if the volcano had moved along the Earth's surface, in reality, the area of molten rock has remained relatively stationary. It is the Earth's crust which has moved. The same is true for the Yellowstone hotspot. Above its magma chamber, the North American plate is slowly sliding to the southwest, about an inch a year. With each new eruption, a caldera is formed and appears to be further to the north.
We find calderas all the way back into northern Nevada, and it's possible that there have been as many as 50 eruptions, just as big as some of the ones that have come out of Yellowstone.
With a history of multiple cataclysmic eruptions, Yellowstone is becoming the most studied supervolcano in the world, and its hundreds of yearly earthquakes, thousands of geysers, and massive magma chamber make it one of the most geologically active regions.
This thing is a breathing system, and it's a dynamic system, so I called it a living, breathing, shaking caldera.
At the heart of these super eruptions is thought to be a mantle plume, an upwelling of molten rock rising from deep within the Earth, but no one could be sure. Recently, however, scientists have been using extremely sensitive monitoring systems to capture data from earthquakes centered around the world. The data has helped create the first 3D image of the source of Yellowstone's power.
Once we put out an array of seismographs with sufficient resolutions, like getting a high resolution CAT scan, we saw that this thing was going off laterally about 150 kilometers to the northwest, and it is basically coming up from a depth of about 600 kilometers.
Yellowstone's magma source begins 450 miles below the surface, and surprisingly,